everybody, welcome back for week 8 of the Graph Adventures with the Wine dataset. So let's get cracking. What are we going to cover today? So for those of you who have been following along on the journey, we've been doing a number of things with the wine dataset that I have found on Kaggle. And again, if you want to get up to speed of what we've been doing, so we've been thinking about how we're going to model the data, we've been thinking about how we're going to import it, all the various data sort of dealing challenges, cleansing challenges, that kind of thing. So all of that's been written up so you can catch up for those of you who are new. And this link here, for the rest of you who've been following along, last week what we did was we imported a description for the wine. So this is the kind of things like the toasting notes, like tastes like melon or some other fruit, or if it has an earthy feel, or whether it was done in steel tankers or like in wooden barrels and that kind of thing. So what we did up until last week, we hadn't done anything with the description. So last week what we did was we imported the description for the wine, and we started to look at what we could do with it. So if you can remember, it's like paragraphs of sort of lots of words, and what we wanted to do was to take that and tokenize it, and therefore start to look at any sort of key words that links wine together. So let's dive straight in. So if I bring up the data model, what you will see, what we've added for those of you who were here last week, is we've now got two new nodes. We've got a description node. Let me just put that on there. And that's linked onto wine. So if you were here last week, I hadn't linked it onto wine because the query was taking a long time. As you will see, if you look into the write-up that I've put in, the reason why was I forgot that I'd put an index on wine ID, not wine name. So that's why it was a little bit slow, but that's okay. If you have a look at the write-ups, again, you'll find that in r.infoj.com/wine-repo. You'll see I've put in the script in there to add that. So anyway, so we've got the description. And then off of description, we've got description word. So description word is basically a word from the description. So let's just do a quick example. So if I do match the description, I'm just going to pull back two descriptions, the limit 2. I'm going to pull back the words associated with those descriptions. So let's do match D, and is description word. Doesn't matter, there's only one of these, but that's okay. And if I just return this back, so if I do return d.value and collect dw.value, we're going to see the words associated with that description. There we go. So you can see what's going on. So that's what we were doing, and some of the things as well we did last week. One moment. Sorry about that. And one of the other things that we were looking at last week as well, a number of things, we were looking at sort of how common sort of stop words were. So things like the and given the data set, things like wine is probably going to be a stop word, winery is going to be a stop word. So we saw a lot of those, but some of the things we did last week was split words by space as well as a hyphen as well as a slash. We used the APOC text clean to reduce everything to lowercase, to remove any punctuation, remove anything that's basically not an alphanumeric number. And the last thing we did as well was we saw that there were a lot of years, lots of numbers that were in the description words, so we removed those as well. So you can get an example here where we've pulled a couple of descriptions, and you can see that obviously these things have been, we've tokenized each of the words, so these are all of the words that are associated with this description. So what I was quite keen to do this week was to go through what we've got and can we get rid of some of these stop words, and we may even decide that actually we want to get rid of words where are used so often. So we've got about 119,000 wines, and if there's a word that relates to say 60,000 wines, we probably want to get rid of it because it's not very useful for us to find some interesting insights into what's going on with our data. We also want to tackle things like plurals. We also spotted some very interesting spelling with some of the things, so I thought let's spend a bit of time to do that. So at the moment we've got about 35,000 of these description words, and let's see if we can bring that right down to a smaller number. So we can probably get rid of about 5,000 or so of that. And then when we've done that, maybe we can start to have a look at things like what is the relationship between wine groups. So wine group is where you've got wine and then sort of Spanish Red 2019, Spanish Red 2018, Spanish Red 2017. So they're all the same wines, the same wine title, but that you've got different years. And what I'm quite keen to look at personally is how does the description change between those wines? So do we see different words connecting them together? Does the year, does the vintage, does something happen to change that? So that's what I'm quite interested in. And if there's any specific things that would be of interest to you to have a look at, so for example, if you've got some questions, put them in the chat and we'll see if we can do them. So I'm specifically interested in the description ones, but if something comes up, if you look at the data model and go, well, actually, there's another question, put it in the stream chat. I hope I'm going to catch both the Twitch and YouTube chat, so I'm using the thing I'm using to restream. So put your questions in and hopefully we'll catch them. And I'm going to, for those of you who are interested to have a look at the code that I've done, I'm just going to quickly pop the link in the chat and away we go. Okay. All right, let's get cracking. So the thing that I was interested in to begin with was how many, what are the popular words. So that was the first thing that I was looking at. So we can do that by just doing match description, and I'm going to do connection to description word. And I'm going to return, so description word dot value, and I want to collect all of the descriptions, and I want to return this, going to return the size of the collection. So I want to order this by the size. Actually, I'm going to with this because I don't want to return the collection, I just want the size information. So bear with me one moment. So let's do with dw and collect d as col, and I'm going to return size of col order by col, size order by size sending. So this is, we're going to see some like the popular words that we did last week. So I've got a question quickly. How to implement delta load on Neo4j and exploring the same user interface. So what you can do, and this is going to be very much driven by your data model, and you need to understand your data. So what you can do deltas, and a lot of that's going to be driven by what your data model is. So for example, if I was going to, let's go with the wine. So let me just quickly scroll to my schema. So to my data model here, so you can see wines here, and so we were loading these wines. We had a row, a new row for each wine in the CSV that we imported. So if I was going to add some more wine, so let's say, so this goes up to about 2017 wines. So let's say I've got wines for 2018 and 2019, and I want to load the deltas for those. So for that, because I know my data model and I know that for each wine, each row, that wine is unique. So I would just load the data. So I'd probably do some kind of a filter and go, so for everything that is greater than 2017 for a wine, just load that data in. So that's me knowing what my data looks like. For something like the wine group, and the wine group is something that, is going to be across covering many wines, then for something like that, I'm probably going to use merge. And what merge will allow me to do is it will basically say, well, if that wine group doesn't already exist, create a new one. If it does exist, then just use a reference to the one that exists, and then I'm probably going to put my connections in for my relationships to connect it to the wine group. So how you deal with deltas is going to very much depend on your data model and understanding the data set that you're loading. If you've got a mix of stuff where you don't know whether it's new data or existing data, you're probably going to be doing some filtering by properties. Again, this will be driven by your knowledge of the data model to handle that. So hopefully that has helped answer your question, Ramesh. Okay, coming back to the description words. So what I've done here is I've written a query and I'm just counting the number of descriptions that have that description word in it. And unsurprisingly, in fact, I am amazed that we've got 2,000 wines that don't have the word and in there, and I'm almost, but not quite, tempted to find out the descriptions that don't have and in it. But you can see that is a super common word, not surprisingly. And then we've got things like the, of, this, with. So these are all the stop words we're probably going to get rid of, and things like flavours in. So we can very quickly see a number of words that we can identify and get rid of. Now the interesting one here, I'm just looking at this and we're probably going to have to make a decision on this, is like the word fruit. So fruit is probably a descriptive word we might be interested in when we're describing a wine. But having a look at this, given that again we've got around 119,000 wines, the word fruit appears a third of the time. So it's an interesting one to think about, and this is coming back to sort of like this knowledge that we have. Is that a word we'd want to keep? Because we're quite interested in tagging some wines that have word fruit. Again, this is something where maybe we dig a little bit further and we discover that actually, we don't need to worry about it, or maybe there's something we can do in the future, the jury's out, where we can use that to help identify, well, what are the fruits? Can we use this word and the structure of the graph to try and take a guess? I'm not sure if that'll work or not, but that's an interesting one. But you can see all the other words like is, aroma, palate, finish, acidity, tannins. Like a lot of these, again, acidity and tannins is an interesting one because most wines have got tannins in them. Or at least, so is it a case of them mentioning it because they're using tannins as a descriptive word, or is it adding something more? And also think like acidity, because obviously you can get some wines that are extra acidic. So it's an interesting one to think about what we can do. And literally just one thought that's jumped into my head is, and we're not doing it for today, and maybe this is something we park in the future and revisit, but I'm wondering whether we can look at the relationship. So you've got this thing called word to vec, where you can look at the relationship of a word with other words, and then you start to identify the importance of them and that kind of thing. And I'm curious, I'm not sure how this is going to work, so I'm going to take a note, and maybe in the future this is something we can explore, but I'm wondering whether we can do something like that so it can help us understand a little bit more about what's going in the description and then apply that somewhere useful. So I'm going to take a note of that right now in my notepad, and then I think what we're probably going to do is maybe we're going to take the executive decision, and we can always reload this data later, but maybe we're going to get rid of a vast majority of these, because these densely connected nodes don't necessarily give us a lot of information about what's going on with the wine. So I think we're probably going to pluck a number out of the air and go anything higher than this, we're just going to get rid of them. But I'm going to take a note about looking at the description for later. Because maybe we'll be able to link fruit to like plums and apples and that kind of thing, depending on how people have done the description. But we can have a little play with that later. So just having a look through here, and then we can start to get things like cherry, and actually we probably care about cherry. So it's going to be an interesting one to try and figure out how do we tackle these. So things like berry are going to be of interest, but you can see they're such common words, but maybe we care about those, and maybe you want to start grouping together fruits, and the interesting thing may well be how these things link in. So that's the kind of thing going on. You can also spot as well, we've got some of the wine grapes in there. And something I'm wondering about or thinking about is we can have a look to see how often do the wine varieties, the wine grapes, appear in the description, and then maybe we can make a decision to go, well, actually we want to get rid of any mention of the sort of wine grape in the description, because that's repeating data. The really fun bit will be, do we discover wines where we don't have the wine grape, but in the actual wine sort of the variety, but we have it in the description, and maybe we can use that to do some fixes. So I'm going to take a note of that as well, because I think that might be fun to see how we compare. So first one to see, do we have repetition of a wine grape in the description, in which case we can probably get rid of it. But the interesting one will be, do we have a mention of a wine grape in the description, but not in the actual thing that we've tagged the wine with, and then we can sort of fix that. So I'm going to take a quick note of that. We can have a look at that in a moment. And again, if you've got any questions, do bring them in, and we will cover those. So look at wine variety in description. Okay, so that's interesting. And then the other thing we had as well is we had we had plurals and we had spelling mistakes. And what we did, we had a look. We used Levenstein similarity. So I'm going to just grab this one as an example. And we used Levenstein similarity. So I'm just going to run this. It's going to take a little while to compare them. And we had to heavily throttle it. We were checking that the words started with the two words that we were comparing started with the same letter. They were roughly similar size within 2-3 characters and that kind of thing, because we've obviously got a lot of descriptions. So we'll look at those in a second. So you can see these, we had and this brought up a lot of sort of spelling irregularities that we had. The other thing that's probably worth having a look at as well is to see how many have got few links. So you can see it starts to drop off pretty quickly. So we just I think I've got up to, I'm showing up the first 200 rows. But you can see very quickly, we've gone from tens of thousands to we're very quickly dropping off into the low thousands. So these ones start to become interesting for us to have a look at, comparing wines with different flavours. And what would be really interesting is seeing the group of wines together and what does that look like. So that's cool. So let's have a look at the rare ones. So I'm going to run this. Again. I'm just going to reverse it by ascending. So just going to let those both run. Give it a moment. And we're going to have to make a decision with these. So I think whilst we wait for those to run, let's start putting together the query that's going to look at where we've got matching components. Oh, there we go. So there we go. So we've got interesting ones here where we've got a size of 1. So much like we want to get rid of the description words where there's loads and loads and loads of connections, we probably want to get rid of the ones where we've just got 1, because what that means, there's only one description, which means there's only going to be one wine that, there's only just going to be one wine that is connected to that. So that's not useful to us. We're not going to be able to map, we're not going to be able to use that word to find how wines connect based on their description. So we can get rid of those as well. But the first thing we want to do is just to make sure that it's not 1 because there's a spelling mistake or they're a plural, or they can be mapped up to a previous word. So this isn't going to be perfect. We're probably going to miss some words, but that's okay. That's how it is. And I think we talked about before that you're not always going to get it perfect, but you want to get it good enough, and good enough will depend on your use case and things. But you can see a lot of these were probably, so you can see here there was probably some kind of character or something joining these together. So we're not going to get them all. And again, if we want to spend a bit more time going through this, we can and clear this up, and maybe this is something we can do for the future, or certainly I can go through the blog post and sort of update these. But for now, it's good enough just for the sort of exploring and seeing what's going on, it's fine. And we can see there's quite a few of these at one. In fact, just out of curiosity, how many of these do we have that are one? So what we can do is, oops, what have I done here? Oh, browser's frozen. One moment. I think when I ran this Levenstein similarity query, it took about 3 minutes. So another minute or so and it will be done, hopefully. Oh. Let's abandon ship. Okay. So if we come back, so let's have a look at how many of these were, where there's only one of these. So let's do with DW size col as size, where size is equal to 1, and we're going to return how many of these we actually have. So how many of these do you actually have where there's only one description word? So what have we done? Put return in twice. I think this one's come. Oh no, I won't restart it. That's fine. So let's just give that a moment to run. Oh wow, oh wow. So bearing in mind we've got 35,000 description words. 15,000 of them have only got one attached to one description. So immediately, so we're going to do a bit of cleanup first to make sure that we've mopped up any plurals and things like that. But immediately we can get rid of a load of those, and then we're going to get rid of probably about 50 to 100 of the highly connected ones. And then we've got a nice sort of set of words to help us figure out how things are connected and how that's looking. Okay, right. So let's take a look at some of the plurals, and what we're going to do for that is, well, an easy one to do actually is we can ask a question about a certain length of a word, and then just see, do the last 2-3 characters differ? So if you think about, we've got 2 ways of doing this. So we can either do like a direct, we compare the 2 words and just go sort of, are they the same bar, the last couple of characters? So, the plurals can end with S, they can end with IES. Obviously, you've got things that end with Y and what have you. But what we could do as well is actually we can use Levenstein similarity as a quick way to just map them and join them. So let's do that. So I'm going to recycle that query. I'm just going to rewrite it ever so slightly. So basically what's happening here is we're comparing 2 description words and we're saying where the IDs are different. So that's just to stop us comparing the same word against itself. And I'm just gonna shuffle this up. So we compare the character first. So what this is basically saying, and check to make sure that the word starts with the same letter. They both start with the same letter, and then this is where we're saying that we want to keep the size within the size difference between the 2 of 7 and 10 and 7 and 10. So basically both words are, so strictly, we'll come back to this in a bit. So we really kept this quite small last week because there was a huge number of words, and we can have a look at the stats in a second to see what the range is for those. But that's just to try and keep it sensible. So we're probably going to have a little think about how we do this in a sort of more sustainable way, because we don't, you think about 35,000 times 35,000 words, that's quite big. But let's have a look what we can do here. And what we want to say is where res is greater than, I think it was 0.88 was where we saw things were a similar match. So let's do this, and let's see what comes back. Hopefully this won't take too long. If it does, we just go back and change it. Okay, that's not too bad. There we go. So let's straight away we can see this is a useful way for us to deal with our plurals, and I think there's like sort of odd spellings as well. So I'm kind of tempted to use this, and this is, oh wow, look at this, it's returned at 12,000 1,134 records. So like we can straight away, this is quite a nice way for us to map these. And again, I'm not feeling too precious about trying to make this perfect. I think just as a principle we can run this, and this is a good way to clean up some of the data. So what we can have a quick thing to look at is, oh yeah, I remember now. So we did have a problem as well when we were looking at this, where one letter could be different in two words, and there could be two significantly different words, and this might join them together to say they're the same. I'm thinking for now maybe we just take the risk and go, you know, it is what it is, let's just do that. So this is a quick way for us to patch some of those spellings. So what I'm tempted to do is adjust this slightly so that we want to, where's my thinking? To do some kind of a way so that we proportionately say what's an acceptable word length. So for example, if you've only got a word that's 3 characters long, comparing it to a word that's 6 characters long is bonkers. You probably want to say that, in fact, we probably want to exclude 3-letter words. In fact, I'm wondering whether we just delete all 3-letter words, because those are probably going to be stop words. So 1-letter words, 2-letter words, we can probably get rid of completely. 3-letter words, question mark. So I'm going to take up this query. Let's come back to this in a second, and let's have a look at our short words and how, you know, what is the distribution of our, what's the distribution of our words? If we do match description word, and what I want to do here is I want to return the size of a description word and how many of them we have that fit that size. Let's do count for that word, and so order by C descending. So this is going to tell us what the most popular. So what's the most popular? What's the most popular word size, if that makes sense. So hopefully this should work. Let's see what happens now. What have I done? Order by C descending. Okay, right. So the most popular word length is 7, then 8. So oh, okay, we've got a word of nothing, so that one can go. That's not particularly useful. And then we've got some long words. That's okay, that's fine. So we've got, that's impressive. We've got to nearly every single letter of the, I know, yeah. Okay, we've got word character of 1. So if you've got 24, that would suggest that 24 out of the 26 letters of the alphabet are there. Okay, that's fine. So what I think we can do is, so the big words seem to be 7, 8, 6, 4, 9, so that's fine, and they're all seem to be sitting around our catch-all. If you remember from our query, we're saying greater than 7, so 8 to 9 characters, so sort of 8 and 9 are there, so we can compare them against each other. So let's get rid of the ones that are 1 and 2, and we'll have a quick peek at the characters that are the 3-letter long words. Alright, so let's get rid of all of the ones that have got a size of 2 or 1. Is less than, oops, wrong way around. That's great, yeah. Where it's less than 3 characters. And I'm just going to quickly make sure we've got the right query here. So let's do at 201. Yeah, sounds right. So let's get rid of that. Delete DW, and that's going to get rid of all of the. That's going to get rid of all of our 2-character long words, or 1-character long words, and our single blank there. So I just realised perhaps I should have done an iterate. Well, let's see what happens. If it doesn't behave, we'll wrap that with an APOC periodic hit. Let's give that a moment. Hey, oh wow, 500,000. Those are well connected, those short words. Okay, so that's great, we got rid of those. Let's have a look at our 3-letter words. So let's do, what were those? Let's dw.value, order by dw.value. Let's see, what have we got in here? Oh wow, okay. I'm feeling like living dangerously, and I've just realised, so what's probably happening, you've probably had like a hyphen, like we got O, like sort of French for water. I'm going to be a rebel. I'm going to get rid of those as well. So let's just ditch those. So we're going to get rid of the 3 characters as well. So I'll just update that I got rid of everything that was less than 4 characters long. Right. That's again probably living life dangerously. The word. I mean, like we probably wanted to talk about things that tasted like egg, but never mind. Or it goes well with eel. You know what? We can always put them back in afterwards. That's fine. That's not a problem. And then what we'll do as well is we're going to get rid of those, some of those, what we thought of the stop words. And then we'll come back and turn our attention to dealing with the rest of these using the similarity. So this is useful. So we know what our common words were. So how many did we have? 769. Quite interesting. I'm quite intrigued to have a look at some of the really long words. What are the really long words in our collection? I'll have a look at that in a second. Okay, right, it's done those. So let's have a look at the long words because I'm curious. I am rather curious. If they're longer than 20 characters long, what are they? So return dw.value. What are our long words? Oh wow. Okay, so you can see what's happened here. So these obviously had some kind of a separator in there. And when we've done the APOC text clean, it's gotten rid of the things that were joining them. So we should probably, let's have a quick look what because there's not that many. We've only got 13 records. So what we can do is we can have a quick look at what were they originally, and not today, but in the future what we will do is we will go and maybe we're going to reprocess the description words and just fix that, but for now we'll just just get cracking and see what happens. So if we let's just have a quick peek at where these are coming from. Description, and let's return the md.value. Let's look at that. Okay, so we've got like the long hyphen in there. They're all the long hyphen. Commas, so for whatever reason. Oh yes, that's a good point. I forgot to put commas in as a separator. Okay, that's fine. That's fine. So what I'm going to do is normally you do comma space, But obviously some of these it's happening where the there's been a comma, but they've not put a space in there. So that's fine. That's not a problem. We can redo that. So we're not going to do it now. I'm going to go through and I'll do all the adjustments for week 7 and what have you. So we'll do the corrections, get that all cleaned up, and then reprocess that. But that's obviously not an activity for now. So we've got an idea what's going on. So in that case, given that I'm going to go away and redo all of this anyway, let's live life dangerously and do a quick clean with the similarity, and then we can do some fun queries, and then afterwards we can do it properly later. I think that seems like a good plan. So let's bring back this query. Just write myself a note about the long hyphens and the commas. Right, so let's bring back our similarity one here. So we've got rid of the 3s, got rid of the 4s. This is keeping it quite small, so we're not looking at crazy numbers. So I'm going to see what happens. Do we suffer if we change this to 11? Is this going to be significantly slower? Let's have a quick peek. What happens? If it is really long, then we'll just adjust it. And then what we can do is we can kind of phase through this, because we're going to get rid of quite a few words and then we can go through it again. And I'm going to get rid of quite a few words and then go through it again. So it's all good. Okay, that wasn't too bad actually. That was pretty fast. And we're looking at around 2,000 records. And this is quite handy because this is a lazy way of us dealing with all the plurals. So okay, let's deal with these. And what I'm going to do is I'm going to recycle one of the queries that we used before when we were doing the grape varieties. So I believe that was in week 7? Oh yes, there we go. So this is what we want to. Is this the one that we want to use? I think we do. I'm going to borrow that. Okay, yeah, that'll do. Let's do that. Okay, so we're not using variety name. Obviously, this is going to be our. Oh, actually, cancel that. I want to go back to the previous query. I'm just going to put this in here. So I'm just going to make this a bit bigger so I can see what's going on. So just copy the same syntax that we've got here. Is description words. Description. So what we're doing is, because if you think about what's happening with our data, we've got these description words and they're being linked to description, and we're going to use that path of the description word that goes through description to get us back to wine. So for example, if we want to find all of the wines that have cherry, you know, cherry's being used to describe the taste, we're going to be using description as our as our path to get us back. So let me bring back the data model. So actually, I've got the data model here, haven't I? So what we're going to be doing is, if you think about what's going on here, is we're going to have a description word here of, say, cherry, and then here was our description of, say, like, you know, tastes like cherry. And here's the wine. So if we want to find all of the wines that taste like cherry, we're effectively, here is our start point. So this is where we say cherry. This is the thing that we're interested in. But we're always going to be going via description to get to the wine. So this is why what we're going to be doing. So let's say we've got cherry and we've got cherries. And obviously they're both the same word. So we're going to get rid of one of those. So let's say we're going to get rid of cherries. So I'm going to stay with cherry. So what we need to do is we need to detach cherry, and we still need to point to the fact that, you know, that cherry and cherries, they're all points of the same, they're going to be points of the same description. So that's why what we're going to be doing is we're going to be detaching and reconnecting the word so that we don't lose that information. So we can still connect everything that tastes like cherry. So that's what we're going to be doing. So we're finding 2 description words, and then we've got our rule here about how it's matching. This is where we're saying greater than 88, so I'm just going to keep that as a threshold, and we can research later. And certainly I would recommend go and have a play and work with the different thresholds and see what interesting things you come up with. But we're going to stick with that because last week we found that seemed to be reasonably good. Again, if we were doing this in a proper way, we'd be a bit more prescriptive about how we select it. But for now, this is just working through the principle. Okay, so we're doing this, and then what we're going to be doing is we've got our width, we've got our rule here, and then what we're going to be doing is we're going to be doing this merge here. So merge D1 is the description word of description. So this is where we're hooking up to make sure to let this description, we're detaching it from this one, and we're going to be attaching it to this description word here. And then we're going to get rid of the D2. Okay, cool. So that's what's going to get rid of those. So let's grab a copy of that and let's run it and give that a little moment. What's interesting, it's always the same sort of pattern, and it's irrespective of what you're doing. If you're doing this sort of data cleaning, you're pretty much always going to be following the same pattern. Am I checking for plurals? Am I checking for misspellings? Am I checking for similar words? When we were looking at the variety, we were looking at double phonics as well. Like, do they sound the same? So there's lots of different things, but it's always the same sort of pattern we seem to follow with this, which is really cool. You know what tools you've got in your toolbox to tackle these kinds of things. Right, so it's probably going to take a little while, so that's fine. We'll give it a few moments, and we just see the number of our the number of our description words is slowly dropping. So the reason it's longer as well is if you think about some description words, we've got loads and loads of relationships. So it's how if this ooms, then I'm going to just rewrite this using the APOC periodic to handle those large number of relationships. So let's see what happens. Maybe I've bitten off more than I can chew here. If it's too much, then we'll just use APOC to help us with that. Again, if you've got any questions, so now if you've got any general questions whilst waiting this run, please do fire them in on the stream chat. So if you've got anything you'd like to know, let me know. Oh yeah, so but I'm trying to think what else did I want to ask when I got this sorted out. I'm gonna have so much fun with this. I love stuff like this. And see how things link together. May have bitten off a little bit more than I can chew here, so. Trying to think what. So. May APOC this in a second. Yeah, let's. Again, I'm all about reusing stuff, so I'm just going to borrow a query that I've. This one, periodic iterate. This is what we want. Let's reuse that. Oh no, this is. So, will this match all the words? Yes, it will. All right, let's see what happens. We can get this ready. If nothing else, so we're going to return D2. Is this the right way around? I'm just trying to... No, it's fine. D1, D2, and D. Oh no, got all of this stuff as well. Hang on. I've got to put this all in. Okay, and then what to do with it? Okay. So I suspect this. Let's rename this. This is going to be okay, cool. Right. I'm wondering whether to make the batch size even smaller. I am going to drop this down to 10, just because we've got some really dense relationships in our description words. Alright, so let's do that, as this is taking a while, and we'd rather be playing with our data than trying to load it. So let's wait a while and see what happens. So the only thing I'm worried about here, that should be fine. That should be fine. And what we'll see, description words drop. So, oh dear. Did check if the database is okay. Did I knock it over? Okay, alright, one moment. I'm just going to quickly just restarting the database. One moment. Obviously, making it work for its dinner, making it work for its glass of wine. Again, if you've got any questions, now's a golden time to get them in. Wine questions. Bonus points for wine questions. Oh, okay. Right, that's it. Let's have another go. So hopefully this will... Excellent. Right, let's try again. So... No dear. So what did I miss here? So let's just make sure. Oh, I forgot to return D, that's where I went wrong. So D1, D2, D, and okay, cool, right. Right, let's have another go. And then what we'll be able to do is we should see the number of okay, let's rewrite it. What we'll do is we'll see the number of description words going down. So you know it's doing something. Excuse me, right. Right, let's give that a little while. And I guess what we can do is I'm going to have a quick look at some of the let's have a look at some of the varieties that map the description words that we have, because I think that's quite interesting. So let's do the variety name. I'm just going to pick a few of these. I'm not going to do loads. So let's do with the limit. Let's do 20. And then let's match description word. Which has the variety name in there. So let's do value is v dot name. I believe we use name for variety. We'll check in a bit. Let's return. Let's return the matching one. So let's do return v.name, and how many of those have we got? So count D. So I know that'll be the same, won't it? v.name. So let's return which ones match. Oh, okay. So bearing in mind we did a limit of 20, and this is just going to pick 20 random variety names in the database. Apparently we've got 19 records that match. So I'm going to... What happens if we get rid of the limit? Like, how many... And then we'll have a look how many we've got in variety names. Oh wow, so we've got 433 records that match. So the interesting one will be to go away and have a look at how many descriptions, how many have got descriptions with the variety name in it, but we don't have a variety name connecting to it. So we'll have a look at that in a second. Let's have a quick peek how this is getting on. So have we seen a marked decrease in the size of stop? We're not. Okay, I think there's something strange going on with that query. So I'm going to stop it, and I'll have a look into that later. So I think we'd rather let's have a look at some fun things going on. So we've got 443 blends. So let's remind ourselves how many variety names we've got. So okay, we have got 510. So 433 out of about 510 are being used in our description. So let's go and find out if we have any wines where we've got a variety name in the description, but the wine doesn't have a variety name. So this should be interesting. So let's do... okay, so we've got 510, so it's not a crazy number. So let's have a think about what this is going to look like. So let's say... okay, so the first pass is we're going to find all of those names. So I'm going to recycle this query here. So what we're going to do is we're going to use all the variety names. We're going to find all of the description words that match the variety name, and then the next part of the query is going to be so with D we are going to match I'm going to call this description description word, so we don't get confused, because we're going to be going to description. So match description word is description word description, and then the wine has a description. Has description. This brings us to wine, and the wine has a variety. And the variety. And the variety has that variety name. So what did we call it? Is component of. Probably might change that later to make that consistent. So variety name. Variety name. Where d.value is not equal to variety name.name. And then what we're going to do is return, because not everything's got a variety name. Okay, we'll come back to that in a second. So I'm just curious what we've got. So let's return dw.value and vn.name. Okay, let's see what happens. Does this run? Okay, so we probably need to double check that query, but it seems that they all do. So let's try where it is equal, just to make sure it's working. Okay, no, there's a mistake in the query. So I'm just going to bring up the data model to see what's going on. So I'm just going to grab a copy of that. And let's remind ourselves of the data model. Okay, right, let's just pop that query back up again. So what have we got? So we have said, so we know the first bit works. We've got value. So, right, match description word is description word to description. And then we've got wine has description to description. And then wine has variety to variety. And then we've got variety name is component of variety. Okay, so what's going on here? Okay, so let's just do, oh, this is going to return a crazy number. So let's do, we're going to limit this by 100, and it's probably going to bring back the same thing several times, but that's okay. Okay, so there's something broken here, and I'm just trying to figure out what have I done to break this. Oh, this, did I spell this correctly? Yeah, value, calendar name. Oh, what is going on here? What have I missed? Maybe it doesn't have a variety. So let's just, I'm gonna do a bit of diagnosis. So what I'm gonna do is just, oh no, let's just do this. So I'm going to remove that bit, and we're going to return. Let's do v dot name limits 100. Oh, I could have been a name. That's fine. That's all good. So do we return stuff here? Yes, we do. I think it's v dot title. Okay. So that works. So let's cycle it to variety. Oh, you know what I've done here? I've spotted my mistake. There we go. I double used a variable. Right, I think we've solved the mystery. So let's do where it's not equal to. Let's see what happens. Hopefully we return something this time around. Maybe I should have put a limit on this. Oh no, we're back. Oh wow, okay. Now that's interesting. So, oh, okay. Oh, okay, so it's going to be for each of the variety names. Okay, so I know what's happening here. So we probably need to throttle this. So what's happening is that you think about the variety name. Remember we tokenized it and there's probably lots of names. So what might happen here is that you think about this Sangiovese probably has, although variety name's a different one, but there's, you know, because we tokenized the variety names as well, and it's going to be crisscrossing, so some of those aren't obviously not going to match. So just need to rewrite this so it's better. So let me give you an example, because if I return v.name, and let's do limit 50, then what you'll probably see is that okay, no, take that back. So I still think what I'm thinking of is happening, but the interesting thing here is we've obviously got description that's talking about Sangiovese, but when we look at the blend, the words being used, the variety name, it doesn't say Sangiovese. So straight away we've got something really interesting here. We can go away and try and fix our data with what's going on there. So that's quite amusing actually. Wow, look at that. So I'm now curious, because I'm just going to bring up the description for that wine. So if we do, let's bring up the description value, and let's bring up the wine title, and let's see what happens, because I'm intrigued now. So you got the so here you can see we've got the wine title, we've got the description for that wine, and then we've got the variety name. So this is what we loaded in. And what's fascinating here is, there you go. So you've got Sangiovese and Cabernet Sauvignon being mentioned here, and we don't have it in the actual variety, grape variety that's been specified for the data set. So straight away, like, that's really interesting. We can take this and we can do some interesting stuff with this. We can basically correct our data. So everything we've got red blend and white blend and all that things, we can go away. We can now do something about that. So that's pretty damn cool actually. I like that. That's very nice. So we'll have to think about how we can use this to correct stuff, because you can imagine that you discover that you like this wine and you have a little, it's red blend, but actually maybe it's the ratio of this Sangiovese and the Merlot and the Syrah that is the thing that you like. So okay, that's fun. So I like that. I'm just trying to think what else can we dig here. So we probably want to taper this a little bit. So what I'm going to do is I'm going to rewrite this query slightly, and we don't need to know we're doing the comparison here, so what we probably want to bring back is the V name and the D name, because that's the interesting bit, and that's probably going to reduce some of the duplication that we're seeing. Or not, that's okay. I'm going to cheat and put a distinct in. I'm just going to grab a copy of this query. Oh, you know what I did? I failed to put in no, it's fine. So you've got Pinot Noir. So I think so not all of these. So what's probably happening here is it's probably comparing the Pinot Noir, and that's fine. We'll have a think about how we fix that in a second. I think that's the last thing we'll have a look at before we call it a day on the stream. But you can straight away see things like red blend. Look at this one straight away. So this has been put in for the variety, and it doesn't mention any of these going on. So that's really cool. So straight away, like a number of times you see red blend, but red blend's got loads of different grapes. So just trying to think. Okay, no, we'll leave that for next time, because I was thinking what we could do is for each one of these words that, you know, each one of the blends that the varieties that doesn't match the grape varieties we've got in the description, we can like do a tally of how endemic this is. I'm going to leave that for now. I'll let you guys can have a go at that. But let's try and figure out how we stop this one from coming up. So you see here, it says Pinot Noir, and it says Pinot Noir. So we're not interested in that one because obviously it's mentioned and we have it. So that's not data we're trying to find. So let's have a quick think about how we can fix that, and then I think we'll leave it there. Okay. So I may have to take this one offline and have a little think about it, actually, because I don't think it's not as obvious as I think so. You know what? I think I'm going to leave it there. I'm going to have a think about this, and let's chat about it next week. So I'll have a little think about it. We can have a catch up next week about how I tackled that, because this is probably quite a common problem. I'll have a diagram as well, and we can look at it. But I'm going to leave it there. But I think the really cool thing that we've spotted here is we have this thing where we've got red blend, but we've got all the grape species that are not coming up. So what we can do, let's do a quick tweak for that. So let's say we've got, so let's go to variety. So where variety, and we're gonna cook this slightly. We're gonna force it down to red blend. So let's say name is red blend. So we're gonna get rid of variety name. I'm not worried about this. So what we're doing here, so remember what we're doing. So we're taking the variety names, and we are saying find all the description words that match the variety names, and then we're then using description words to find all the ones that have got the word red blend. And then let's return here. This bit we don't need because we've forced it to red blend, and let's return distinct description words, because actually that is interesting. And let's return we know what the red blend is. So let's just return all of the description words that have been described as red blend, and then afterwards what we'll do is we'll do it by wine. So let's do that to begin with. Let's see all of the different wine blends that have been chucked together under red blend. 185 different reds grapes have been bundled under red blend. So the next fun bit is going to see, well, okay, so what are the groups of those? So what we're going to do is, if we do, let's do this. So let's do, actually let's do wine.title, and then we're going to return the collection of the description words. And there'll be quite a few of these, so I perhaps should put limit in. That's not too bad. Okay, so that's interesting. So you can see straight away, obviously we know we've got blend in there. That's fine. That's one of our tokenized words. But bearing in mind that all of these wines, and that's like some 6,675 wines, have got the grape variety of red blend, It's quite interesting, like how many of these we come back. So the next bit that I'm quite keen to investigate is what are the common groups of wines put together as a blend. So if there's a quick way to answer this, we shall. Otherwise, I think we're going to leave it as is. So let's have a quick look if there's a quick way of doing this. So what we could do is, I think, if we do... So let's do it with wine, because that's the thing that's keeping this unique. And DW order by DW dot value. And then let's do with wine collect DW as grapes. Is this going to work as expected? Return. Grapes. Count grapes as popularity, order by popularity descending. Right, let's see, does this work as expected? I'll grab a copy of that in case it does. Oh, okay. You know what I've done? I forgot to return values. That's fine. We're going to quickly correct that as it didn't take too long. So what we want to do, value as grapes, and then we're returning that. Okay, right, let's see, that should hopefully work. Okay, no, that worked, that's good, that's what we wanted to do. So we can okay, so we've got things like black and blend. Okay, we can investigate that later, what that is all about. But we can see like Cabernet Merlot Sauvignon, like that's a popular mix. We've got Cabernet Merlot Sangiovese Sauvignon, so we probably we've got some stop words here as well that we'll need to get rid of, and that's fine. So we talked about, we probably had some of those in the varieties last time. But that's interesting, so you can start to see what are the popular groups. So, okay, that's cool. That is very cool. So can I get rid of... I'm just quite keen to just get rid of some of these words just so it looks a bit more interesting. Where v dot name is not in. Okay, let's do black. Let's do red. White. Blend. And what else did we have in here? Quick eyeball. Style. God, no, we'll get rid of style. Probably should check black. Discipline discover that black actually is a grape. I've not come across it before. Rosé. Okay, that's fine. You know what? For the other. Let's leave it at that for now. But this is just the last query. Then that's it. We're going, but just to see what happens. Oh, we're not. Ordering magic. Okay, right. Let's have a look. Oh, that's fun. Oh, just spotted a question that's come in. Yeah, absolutely. You can use Neo4j for knowledge graphs. In fact, if you just put a search in for Neo4j knowledge graphs on Google, you will find loads of stuff. Certainly a lot of my colleagues have done various webinars and things on doing knowledge graphs with Neo4j, and I just see Ramesh as well has put an answer in for that. But yes, very good fit for that kind of thing. You think about this, like we're talking about the wine data set, and this is like one could argue this is a knowledge graph for wine, and what we're doing is we've taken this data set and we're using graph structures to help us make corrections to our data set, and it's building in the knowledge. So as an example here, you know how we had the variety of grape, which was a red blend, which is what we're looking at here. We've now, based on our data set, we're getting a view of what are the popular wine grapes that are used for red blend, and we're doing that based on the description. So we've got the description of the wine, we've tokenized the description of the wine, we've used information from variety, where we look at all of the variety grapes in our database. We go, well, okay, these are all of the grape varieties that we have. We've used that to cross-correlate against the description to then pull out all of the descriptions that have got wine blends, and then we're going back and going, well, all of those wines that have been tagged with a red blend, now what we're doing is we keep going back and forth using the structures of the graph to help us figure out, well, these are all of the these are the grape varieties that should have been in the we found in description that should have been in the variety. And that's exactly what we're doing here, and this is what's really cool, because now we had like some 6,000 wines with red blend they'd been put down, and if you were looking at a wine guide and going, well, okay, this is a red blend, this is a red blend, this is a red blend, now we can say, well, actually these are the grapes that are in that red blend. And you can see here, for example, that based on our data set for red blend, Cabernet, Merlot and Sauvignon are the most popular grape combinations under red blend. So that's really cool. So I mean, if anything, I mean, it's a very basic idea, but this is, you know, how we're using this as a knowledge graph to understand the wines that we've got. So that's really cool. We've done this. So there's a lot of fun to be had here. That was really exciting. And let's do white blend quickly. Let's keep it even. I know that there'll be some white drinkers out there, so let's do that. So I've got to spell white correctly first. So let's see what comes back for white blend. I'm very excited now. Okay, that's interesting. I wasn't expecting apple, orange and melon. So, although I guess you can get apple wine. There is apple wine. I've had apple wine before. A friend of mine from Germany sent me over a bottle. Skipping these aside, but what's interesting, so you can see, I wasn't expecting this as being a popular blend. But you start to get the idea of what's going on here. So, yeah, that is very cool, actually. I've got sparkling as well. That's another one. Let's do sparkling. Last one, I promise. Because we have got sparkling as one of the wine blends. So, let's see what comes back. Oh, nothing. All right, we'll have a look at what the word was for sparkling in. Actually, it would have been capital S. Forget that that's not been. No, all right, we'll have a look later. That's not a problem. But you get the idea of what's going on there. So that's really cool. And the really exciting bit about this is that we've been bouncing back and forth. Do you see how we've been? So effectively, what we've done. Let's bring up the schema again. So effectively, what we've done is, if you think about the data that we've loaded, so we loaded the wine title, and then we also, in our data set, we had, I can show you here, can't I? If we go back to the start. So you remember when we're loading the wine, so this is the description that we've been looking at today, but we loaded the wine, and we had, variety. So there you go, there's white blend. We loaded the wine title, and, we've looked at the description. And what's really cool here is, like, we've got loads of these wines that say white blend, Portuguese red. Sometimes we've got the actual grape variety in there. And what we've basically done today, which is, I think, very cool, is, so this is the data we loaded. So we've loaded wine. we've loaded description, we loaded the variety, and what we've effectively done is, so was it last week or the week before, we took the variety, so for example white blend or Pinot Gris as the other one I had in there, and we've tokenized that into like all of the words there. So in this example will be white, so a variety name called white, and a variety name called blend, or a variety name called Pinot, and a variety name called Gris, if you think of like the blends, so forth. So we've done that. And here, so some of them obviously we've got red blend, white blend, but we had something like 433 variety names. So in there we grabbed, hopefully we've got all of the different wine grapes, that are sensible there. So we've done that piece of work. Then today we've been looking at description, and we did some of the tokenizing last week as well. So we've got the description, and then same idea, we've tokenized all of the words in description, and some of the descriptions have got wine grapes in there. So they've got some of the varieties in there. So what we've done is we've done a first part of the query where we go to variety name and say, well, let's find, without doing any kind of looking at any graph structures, find out all of the description words that match to variety name. And the idea there is that most of the variety names should be all the grape varieties. So we've done that. We've pulled out the 360 odd description names that match the variety names. And then what we've said is, okay, now that we've got all of the descriptions that match the variety name, description words that match the variety names, what we're doing, now we're using the graph structure. So we're going from description name to description because they're connected, to wine because the description is connected to the wine, to the variety, and then to the variety name. And what we're saying is we'll bring back where the variety name does not match the description name, which would suggest that that variety name does not have the actual grape, and we've used words like red blend. So effectively now using the graph structure to build that knowledge around, well, what are the blends, what are the popular blends? If we wanted to go back and do some corrections and go, well, we don't want red blend, we actually want the grapes, we can now go back and forth using that structure to make those corrections, and that's really cool. So that was fascinating. So have a go yourselves. I will give me a few days. I'm going to update the repo and I'll get that corrected for you. So just to remind you, that's the address there. So go away. I'm going to move on. I think we're done for today. So I will have all of the updates on there. So do have a go. See, I'd love to hear what kinds of things you come up with when you're looking at the structures. If you've got any questions, if you think of any wine-related questions on this data set you want me to answer, either bring them with you next week when I will be back, or you can send me a message on Twitter, so tweet me or send a direct message on Twitter with your question, and we'll cover it next week. So thank you very much for joining me today, and have a good one.